So now we want to try some practice based on what we just learned about secants and tangents, as well as what we already knew about chords. Now, this question asks us if BC, line BC, is secant, tangent, or a chord for circle A. And you might wonder, how could we figure that out? Well, remember, we just talked about in the last bit of the last video, we just talked about that if we could prove that a line was perpendicular to a radius of the circle, where it touched the circle, then we could prove it was a tangent. So essentially, if we could prove that there was a right angle right here at angle ABC, if we could prove that that was 90 degrees, then we would be able to show that that was in fact a tangent line to circle A, because it looks to me like it only crosses the circle one time. It looks like it only touches the circle at B, but we need to be able to show that and to prove it concretely. The only way to do that is to show that we actually have a right angle here. Well, how could we show that there's a right angle? Notice we have some lengths that look like triangle lengths here. We have 8, 15, and 17. In fact, those are all the legs of this triangle. If we could prove that this is a right triangle, triangle ABC is a right triangle, and it has a right angle there at angle ABC, then we could prove that it in fact is a right angle at ABC. And that's what we're going to do. So we can use the Pythagorean theorem, or really the converse of the Pythagorean theorem. Remember, a squared plus b squared equals c squared. Remember, the Pythagorean theorem is only true for right triangles. So if it proves to be true for our 8 squared plus 15 squared plus equals 17 squared, not plus, equals 17 squared, then that would mean that this is in fact a right triangle, and that shows that it's a right angle at angle ABC, and then that would mean that that is for sure a tangent. BC is for sure a tangent. So let's try it out. 8 squared we know is 64, plus 225. That's equal to 17 squared. Well, 17 squared is 289. And in fact, when we add up 64 plus 225, we get 289 equals 289. That means that triangle ABC is right, which means that BC is tangent. So we have now shown, because it's a right triangle, that BC is tangent. Remember, by definition, a secant crosses the circle twice. So we could see already when we look at BC, it does not look like it crossed the circle 2 times. Look at that. It does not appear to cross the circle 2 times. It appears to be a tangent. It appears to intersect at one time. And a chord is, again, it's just a portion of a secant. It starts and ends on the circle. This one is definitely not a chord. Could have crossed that off immediately, because a chord is just a portion of a secant line. It starts and ends on the circle. This goes on forever and ever. It's a line. So it had to either be a secant or a tangent. It appeared to be a tangent, and we were able to prove that it in fact was a tangent. Let's look at another example. This tells us that line BC is tangent to circle A at point B. So we know that it's tangent at point B. Notice we have a radius drawn out to that tangent line. So that means right there that that's a right angle based on that theorem that we just looked at. And the question is asking us, what is the measure of angle CAB, so right here, if we already know the measure of angle ACB is 72? Well, we can figure that out pretty easily, knowing that this is a right angle at angle CBA, because now I know that those 3 angles have to add up to 180. So let's just name angle CAB, we'll name it X, plus the 72 degrees, plus the 90 degrees, that right angle that we know is there. Remember, that has to add up to 180 degrees for that triangle. So we have X plus 162 equals 180. To solve for that X, we subtract 162. And we end up with X equals 18 degrees. So that has to be C there. Because we knew that that line was tangent to the circle, we knew there was a right angle at CBA. They told us that angle ACB was 72, and we just used the fact that there's 180 degrees in the triangle to find the last angle, which was 18 degrees.